All right, so now we have a bunch of activated electron carriers in their reduced form, right? So we have a bunch of NADH and FADH2, but this is where most of the energy from glucose now is in this step. So we're going to need to convert that into ATP so that we can use it in our cells. So we're going to take this reduced NADH and we're going to oxidize it to make NAD+. We're going to take FADH2 and oxidize it to make FAD. Now this FAD and this NAD+ are going to go back into the Krebs cycle, which remember is still in the matrix, and then they're also going to get reduced again and come back, and the process continues on and on. So when these are oxidized, they're losing their electrons, so the electrons will keep moving down, and eventually it will be given to our last electron acceptor, which is going to be oxygen, and then oxygen is going to combine with hydrogen ions and make water. Remember, water is also one of the products of cellular respiration. Now keep in mind, oxygen is very important because this whole part of cellular respiration happens in the mitochondria, which is only present in anaerobic, like cells that do aerobic respiration. So each time an NADH is broken into an NAD+, and an FADH2 is broken into an FADH, that energy that is released from those reactions is going to be used to pump hydrogen ions across the inner membrane of the mitochondria, and then we're going to have a higher concentration of hydrogen ions in the inner membrane space, so the intermembrane space. So this is what we call the electron transport chain because it's transporting these electrons, and the purpose of that is to create this voltage difference, this charge difference, because this side becomes a lot more positive than the inside the matrix over here. And also it has a higher concentration of hydrogen ions, or it makes it more acidic, or a lower pH. So this is what we call an electrochemical gradient, and this is potential energy. Now in the next step, where we have chemiosmosis, we're going to take that potential energy and harness it to create ATP. So we're going to take these hydrogen ions and we're going to bring them back down, and in doing so, we're going to harness their energy. So there was energy taken to bring them up. That was active transport. We did some work to do that. Now this one is not, this one is just coming down and it's not doing any work, but we are taking the energy and we're using it to combine ADP with a phosphate to make ATP. And then again, the hydrogen ions are now in this low energy state, so they're going to combine with our final electron acceptor, which is oxygen, and they're going to form H2O.